Welcome to Introductory Statistics using SPSS, Module 7, ANOVA Test Run and Interpretation. An ANOVA test is similar to the t-test, but instead of comparing the means of only two groups, the ANOVA test compares three or more groups to determine if any of the groups statistically significantly outperform any of the other groups. We'll look at this graphically. In a three-group model, here's Group 1, and here's Group 2. When it comes to comparisons, we can compare the mean of Group 1 to the mean of Group 2. But we're not finished. When a third group is involved, there are more comparisons that can be made. We can compare the mean of Group 1 to the mean of Group 3, and we can compare the mean of Group 2 to the mean of Group 3. Specifically, Group 1 would be the control group, Group 2 would receive some treatment, and Group 3 would receive a different treatment. The ANOVA test reveals if there is a statistically significant difference among these groups. In this example, Group 1 is the control group and receives math as usual. Group 2 is a treatment group, which will get Z-math. And Group 3 is another treatment group that gets flashcards. The ANOVA test will reveal if the means from any of the groups are statistically significantly different from each other. The post hoc test will identify which pairs of groups, if any, are statistically significantly different from each other. Let's go into SPSS and see how this works. Here we see two variables. The first variable indicates the group of each participant. Group 1 is math as usual, Group 2 is Z-math, and Group 3 is flashcards. The second variable indicates each participant's score. To order the ANOVA test, click on Analyze, Compare Means, One-Way ANOVA. Load group into Factor, and load score into the dependent list. Click on Post Hoc. The post hoc test will produce a p-value for each pair of groups so that we can determine which groups are statistically significantly different from each other. Since the n for each group is 30, select Tukey. If the n's for each group were different, then we'd select SIDAC instead. Click Continue. Click on Options, and under Statistics, select Descriptive and Homogeneity of Variance Test. Click Continue, click OK, and it'll process. We can now finalize the pre-test checklist criteria. Criteria 2, normality, was satisfied when we ran the histograms with normal curves in Module 6. Criteria 1, which specifies that the ANOVA test becomes more stable with an n of at least 30 per group, can be confirmed by observing the n column in the descriptives table. Also, notice that this table provides the means for each group. 75.77 for math as usual, 80.97 for Z-math, and 80.63 for flashcards. These means will be useful when discussing the results. As for criteria 3, the homogeneity of variance test rendered a significance, or p-value, of 0.752. Since 0.752 is greater than the 0.05 alpha level, this suggests that there are no statistically significant differences between the variances of the groups. Hence, the pretest criteria of homogeneity of variance passes. Now we can move on to the actual outcome of the ANOVA test. Here we see a significance, or p-value, of 0.029, which is less than the alpha level of 0.05. This suggests that there is a statistically significant difference between at least one pair of the groups, but at this point, we don't know which groups are statistically significantly different from which. For that information, we turn to the multiple comparisons table produced by the post hoc test. The multiple comparisons table systematically pairs the groups two at a time and indicates if there's a statistically significant difference between each pair. The first comparison is between math as usual and ZMath, which renders a significance, or p-value, of 0.045. Since this is less than the 0.05 alpha level, this suggests that there is a statistically significant difference between math as usual and ZMath. The second comparison is between math as usual and flashcards, which renders a significance, or p-value, of 0.066. Since this is greater than the 0.05 alpha level, this suggests that there is no statistically significant difference between math as usual and flashcards. The final comparison is between ZMath and flashcards, which rendered a significance, or p-value, of 0.987. Since this is greater than the 0.05 alpha level, this suggests that there is no statistically significant difference between ZMath and flashcards. This concludes this module.